Hello student, the question says two beats are released from A simultaneously to slide along smoothwise AB and AC. Find the ratio of time taken for them to reach B and C respectively. Here, don't be confused with this circle. This circle is given only for reference. The body is actually traveling along the path. So it is actually traveling, one body is traveling from A to B in this way. Another body is traveling from A to C in this way. That circle was given only as a reference so that we can solve the problem easily. But the actual path of the body is this one. So it is traveling in this way. That's the first thing we have to understand in solving this problem. So the first thing is that it is actually traveling along this path. This is A, this is B, and this is A, and this is C, theta 1 and theta 2. So one body is traveling along this path, another body is traveling along this path. Now, what's the importance of circle here? Why do you think that circle is given? Let us see. If I consider a circle and consider a arc in a circle, it could be any random arc in a circle. So let me take this arc one. This is the arc and this is the chord. Let us assume AB as 2 points. If you want the length of this AB, so let me take the center somewhere here. So once I connect these 2 points, this one point and this another point, if this is the center of the circle, this would be R, this would be R. And in the question it is given this angle is theta. And remember, since this is R, this is also R. If this is theta 1, this one also would be equal to theta 1. So first thing you have to understand is that if this is theta 1 in a circle, this angle also would become theta 1. And not only that, we can find the length of this AB also. How do we find the length of the AB? Let me just take a perpendicular here. If we consider a perpendicular here, if this is R, so you can draw the, if this is R, this is 90 degree, and this is theta 1, we can resolve this R into two components. This one would become R cos theta 1, and this one would become R sin theta 1. So based on that logic, this one would become R cos theta 1, this length would become R sin R cos theta 1. So finally, length of AB is equals to R cos theta 1 plus R cos theta 1, that is 2R cos theta 1. So for this problem, the total length of ABB R cos theta 1. Same logic, the length of AC would become 2R cos theta 2 using the same logic. So once we got those lengths, let us continue the problem in the next page. Now, the importance of circle is completed. A body is sliding from A to B, and we got the length of this as 2R cos theta 1. So this angle is theta 1. How are we supposed to find the time taken here? To find the time taken, we know gravity acts downward and acceleration due to gravity is g in this direction. G downwards. If this is theta 1, we have to resolve this g into two components. We need to find acceleration. This is actually a Newton's laws of motion problem. So we have to resolve this g along the incline and perpendicular to the incline. Along the incline, g sin theta, g cos theta 1. And perpendicular to the incline, g sin theta 1. We will later know in NLM that g sin theta 1 would actually be balanced by normal reaction. So there is no importance for this. G cos theta 1 is important. So length, we got it as 2R cos theta 1. Acceleration due to gravity is g cos theta 1. Anyway, initial velocity is 0. We have to find time. Which formula has all these? If we try to find, we got s equals to ut plus half at square, and we'll get t equal to root 2s by 8. So root 2 into s value is 2r cos theta 1 and a value is g cos theta 1. So you will get root 4r by g. Interestingly, we got the time required to slide from one point in a circle, like along the path which represents the chord, is independent of the angle theta. You do the same thing for the other one also. For the other one also, everything else would cancel out, and again we'll get t2 equal to root 4r by g. And with this, we can imply t1 is to t2 equal to 1 is to 1. The most important thing in this problem is that suppose it could be any body. If you take a random circle and two bodies have simultaneously, the word simultaneously is important, has started from the same point in a circle, and let us assume it reached any random point, some from A, but it has to be the other point also must lie on the circle. Let us say we have selected a path which does not lie in the circle. Let us say it went from A to B. It is very hard to solve these kind of problems. If the other point is also on the circle, so like the previous one, some random point B, and from here to here, another random point C, again to travel from one point in the circle to the other point in the circle. It could be some other random point also. Like I can take a very small point in this path, some D. So if the other point is on the circle and both start simultaneously, if all the bodies start simultaneously at the other points on the circle, and remember, the body is not traveling on the circle, it is traveling along these paths. So in these cases, the time required is equal for all the cases. Time required is equal for all such cases. We have just proved it. So the answer would be 3, 1 is to 1. Yeah. Like